For this problem set, we are dealing with Pythagorean theorem, specifically finding the length of the side of an unknown from a triangle. The only real challenge with this particular objective is remembering which of the values goes with which element of our formula. So the hypotenuse is always the longer side of a right triangle, and that's always going to be our value for C. Now sometimes, and in our first problem for example, that's our unknown value, is the hypotenuse. So to solve this, it's just a simple matter of saying, okay, we're going to use 280 for our A squared, so 280 squared plus 385 squared for our B value. It's going to equal C squared. So we'll do those computations and then take the square root. That's pretty simple, pretty cut and dry. The challenge comes later when our unknown is not our hypotenuse, but we'll get to that in just a moment. So go ahead and pause the video, run your computations. Feel free to use your calculator, as I am going to, because I can't mentally do 280 squared. And then verify your answer in a moment. All right, so hopefully you got a value similar to 476. Now, something I want to caution you against is you want to be careful when you're keying this in the calculator not to do 280 squared plus 385 and then square that. Make sure you're squaring these numbers independently before you add them up, because if not, you run the risk of getting 280 squared, which would be 78,400, then adding 385 to that, and then squaring that sum. Remember, you don't want to sum until you've gotten the square of both. And then once you have the square of both, then you sum them together and then find the square root. So for this problem, once again, we're using Pythagorean theorem. We're trying to find the length of an unknown side. As with question number 1, our unknown side is our hypotenuse, and we're given just a very simple diagram of a triangle. Now, I will tell you, my triangle is not to scale. It doesn't match the drawing, so don't let that confuse you. Just remember, your A value and your B value, they're going to ultimately be smaller than the C value. So just something to keep in mind when we run our computations. So I'm going to use 3 for my A value and 9 for my B value. Really, with these sides, it doesn't really matter which one you use for A, which one you use for B. Hypotenuse though has to be the C value. All right, so we're going to do 3 squared plus 9 squared gives us C squared. I'm going to go ahead and do this. I'm just going to go ahead and write this out. So 3 times 3 is 9. 9 times 9 is 81. Then we're just going to find the square root of 90. And we're going to get about 9.5. So this particular problem is going to present a little bit more of a challenge than what we've had up to this point. Now, the first thing we need to identify is that we are not going to be looking for the value of the hypotenuse. We're actually given that. The other thing is we have 2 different triangles that we're going to be working with. So our question asks us to find the distance between K and P, from this K vertices to this P vertices, or vertex, excuse me. Well, to find that value, you have to find this Km length, and you have to find this MP length, which means we're actually going to have to use the Pythagorean theorem twice in order to get these values. All right, so let's start with the KLM triangle. We're going to ignore this one for a second. So I'm going to use 3.4 as my A value, so 3.4 squared. This will be my B value, and actually I'm going to stay consistent in just a moment. I'm going to use this for my B value as well. So B squared, and then C squared is the 3.7. So remember, the hypotenuse, that's our value for C. Now, this is where some of you might get stuck and make an error, is if you just do 3.7 squared plus 3.4 squared and then find the square root, that's not going to give you the correct answer. You've got to make sure that your C value is the hypotenuse. All right, I'm going to go ahead and punch those into the calculator. So 3.4 squared is going to be 11.56. Please be following along with me as I do this. 3.7 squared, 13.69. Now I need to subtract this 11.56 from both sides. So b squared is going to equal 2.13. And then I find the square root of 2.13. And I'm going to treat that as 1.46. I think going to the hundredths place would be just fine. So for this first, for Km, and I'm going to go into erase, well, I'll just do this. For Km, we've got 1.46. All right. Well, now I have to do the exact same thing, except I've got to do it for this second triangle. Now, the good news is that some of my values are going to stay the same. So what I'm going to do, for the sake of room on your screen, is I'm going to keep my answer down here, but I'm going to erase what I don't need. And just fill in my new values. So my hypotenuse for this triangle, this LPM triangle, is 3.6. But my value for this side is still 3.4. So I'm going to leave all that in there, and now I'm just going to find 3.6 squared, which is 12.96. Subtract 11.56 from it. You get 1.4. Take the square root, and I get 1.18 for my MP segment. And now, to find from K to P, I just need to add these two numbers together. And I'm going to get 2.64. All right, so for this problem, we're given a real-world situation where we have a ladder that's leaning up against the building. It's a 13-foot ladder. It's 5 foot away from the building. Now, again, we have to be cautious here to make sure that we're recognizing that the ladder is our hypotenuse. That's our C value. So as we're substituting these values in, we're going to have 5 squared plus b squared equals 13 squared. We have to make sure that we have the 13 in the correct spot, because if we do 5 squared plus 13 squared and then take the square root of that, we will get the incorrect answer. We will not get a correct answer in that if we do it that way. So we've got to make sure we're plugging these values in to the correct spot. All right, 5 squared is 25. 13 squared, yes, I am using my calculators, 169. We're going to subtract 25 from both sides to isolate b squared. Gives us 144. Square root of 144 is 12.